We're back with part two of identifying requirements and assembling the network. I just listened to where I left the last nugget just to kind of refresh myself, reorient where am I going, and I'm psyched. Seriously, I feel like I don't know. I feel like I'm just conveying some really good stuff just so early on in the series of it's the stuff that you miss in the CCNA. The CCNA is great to talk about the OSI model and all that, and here's how you configure a VLAN and set up switch ports and so on, but it's almost like it misses the whole culture of designing and implementing networks. And maybe I don't know. I don't even know if it's something that you can put a curriculum to, other than just kind of hanging out with somebody who does it every day. Not to at all say that, oh well, I've got it all together. I don't. I trust me. I really have a lot of growth to do in a lot of areas, but I can tell you I've done this enough that I can pass on some really good stuff to you. So what we're gonna do in this nugget is pick up where we left off. Last nugget we left off talking about the requirements document, kind of planning the phase one of it all. And now we're going to get into the point of, let's start off with brainstorming the project. And I'm actually going to camp out on this slide, kind of use this as my theme as I go through. Now, we came out, actually, a matter of fact, I showed this to you in the last nugget. This is my miniature project plan, my wannabe Stephen Covey 7 Habits of Highly Effective People system that I create for myself. And we, in the last nugget, met with the corporate group. We read through the scenario, which was really generated from a meeting with corporate entities, the on-staff Windows guys. And we got together, created that questionnaire, discussed the upcoming branch office rollout, some of the questions to ask and things like that. We materialized it by putting it all into a requirements document. We'd say, okay, this is what we're going to do for you. And then the second thing is my mind just already jumped to another topic. Hang on, come back, mind. So we put the requirements document saying this is what we're going to do for you, and here's the assumptions that we're going to be making as we go through and set this up. So just so everybody's on the same page, that requirements document, let me bring that guy back into the picture. It is right here. That requirements document was going to be emailed to everybody in the company, or everybody everybody was at that meeting, so that everybody has got it. We're all on the same page. You get your read receipt going on, and now you're good to go. Okay, so that's where we left off. Now we come to some of the big places. One is assembling an equipment order. And it's funny because I looked at that time, just as I pulled this up, I'm like, yeah, right, Jeremy, you're wishful thinking right there. Let's double that, just because it always takes more time to assemble the equipment than what you think. And so again, my mind goes into a billion direction with this. So let me take you in the direction of kind of brainstorming the project. I know it says right there on my project plan, equipment order, but I always do some brainstorming beforehand. And you can see on my little OneNote tabs, I've got requirements document, right underneath it, brainstorming. So what I did, and seriously, just to set up this initial nugget, it took me some time because I planned this out just like I do any project. Just said, okay, this is a real client. Nugget Labs is a real client. Here's what I would do. So brainstorming, I sat down, I said, okay, this building is 2 stories. I kind of put down, okay, here's what I know. 2 stories. First floor, MDF, is going to house 50 users, servers, etc. Wireless access points, IP phones. We've got all that going down on the first floor. We've got the second floor IDF. Initially housing 25 users, but we know this building is growing. We don't know how big or what floor they're all going to go on. We just know it's going to grow to 200 users should this company's plan work. So then I start brainstorming. Okay, Wi-Fi. That's one of the things that they mentioned. We need full coverage for the first and second floor. So again, these are just brainstorming. I'm just typing as I'm thinking. I need to perform a wireless site survey. So you might say, well, what's that? Wireless site survey can be either way technical or way winging it. And I will say most of the time I'm winging it. You can get all kinds of awesome tools like Fluke Networks. Matter of fact, if you guys watch this and you're like, dude, I totally want to hook you up, Jeremy, let me donate to your cause. I should get like a little donate to Jeremy Page, and put a little picture of what I want. Fluke Networks has this, like I would get anything. Fluke Networks has this little, it's yellow. I know that. It's this handheld widget, which literally you walk around, it's telling you ranges of Wi-Fi access points, how far, the reach is. It's showing you interference. Somebody kicks on a microwave. It's like, whoa, microwave's leaking. You're interfering with it. So all it does everything. So that's what I would call a way technical site survey. Which that little gadget, I think I priced it was like $8,000 some for a little handheld thing. So anyway, that's the donation page. For me, I do way non-technical. I had until Apple revoked it. I had a wireless sniffer for my iPhone. Yeah, that's my Fluke Networks replacement. And I literally will install an access point. I'll walk until the signal reaches about 20 to 30%, this little iPhone app on my phone, or I carry around a laptop. There's plenty of open source freeware kind of tools like this. And as soon as it reaches about 20-30% signal, I go, okay, I kind of, on my diagram of the building, I say, okay, this is where the reach is. I draw the little circle hang on, let me grab my pen so you can see. So I've got, here's my building map and floor plan that the contractor gave me, and I'm walking. I go, okay, right about there. That's where that one ends. So I'm going to need to put one right there so I get some overlap with the other one. And then I'm walking around right about there. Okay, and so I'm designing all these little spheres. This looks like some kind of Egyptian map, but it's not really. I design all these spheres just walking around. Now keep in mind, this is like budget conscious. Remember, one of the things that they said is they wanted to go with small business access points. One of the great things, I don't know if any of you have heard of this gadget. It's called a wireless controller. It only takes once. One experience with a wireless controller and your life will be changed. What a wireless controller does is it combines with these things called lightweight access points. You essentially have a controller. It's priced based on how many access points it supports. Maybe like a 50 access point wireless controller might be like $12,000. They're not cheap. So they don't have to plug directly in, but I'll show it here. You put all of your config on that wireless controller. All the SSIDs, the security standards, everything like that. And then your access points literally plug into the network. You just go, plug in the cable, and you're done. They find the wireless controller. It's via DHCP address. It actually detects the wireless controllers, goes, there it is. Let me download my config. Bam, I'm configured. It's like a mainframe dumb terminal kind of configuration. I'm telling you, once you use a wireless controller, you're like, how did I ever do this without these things before? So they're awesome, right? But not every company can afford those things. But the reason I bring it up right here is the wireless controller does the work for you. It actually is able to start piecing together. It goes, whoa, I see this one's got a strong signal overlapping too far. So it'll lower the strength of this guy so it doesn't overlap. It kind of just does the wireless config for you. And so a lot of the wireless controllers even suggest, it'll be like, hey, you need to go put one right there. And anyway, I could go on wireless controllers for a while, but we don't have one. That's I guess my point in this picture. So I said, okay, need to perform a wireless site survey. What I start doing in my notes as I'm brainstorming is I put it bold. I put it in a different color. I say this is an on-site task. So I know that I need to go on-site, and what I do is I start putting, going back to my little project plan, I'll say, okay, task list, I'll say priority 2, Nugget Lab, on-site visit. Assign, this is how sad it is, how slow I go. It's now, what is it? What am I? No, it's not too bad. It's the 10th of November 2011. So I put that in there, on-site visit, and I'll say that's when it's sent, or that's when it was scheduled for, and then I'll say Wi-Fi site survey, depending on the size of the building. Maybe that guy is a good 2 hours or so, just walking around, getting a good feel for where the access points are going to go. Again, I always under budget my time. So I would start creating an on-site visit list just by doing my brainstorming, and everything that it needs to be on site I'm going to flag. I need to know that I need power over Ethernet switches or couplers because the access points need to get power from the Ethernet cable. It is a pain to try and run plugs or use these little inline couplers or something like that to power the access points. So just do yourself a favor and get the PoE switches, especially knowing that we're going to be rolling out voice over IP. We got to have those things anyway. So voice over IP, I think, okay, IP phone per cubicle office. Okay, that's going to give me that additional 5 to 10 foot Cat 5 E or 6 Ethernet cabling for a patch. So I'll assemble that in my order. That was one of the things that I put in my requirements document. I said all the devices will be 5 to 10 feet away, on average 5 to 7 feet. So then that's where I start going, okay, brainstorming wise, and this is what takes the time right here. I start brainstorming items needed. Now, a lot of people just call a sales rep, and that would be the smart people. There are sales reps who are trained, they are paid to know all the different products. I Google. I love Googling. I don't know why, it's just an addiction. I'm like, oh, that's cool. Oh, that's cool. So I like putting it all together myself, but I'll explain more later when you see my equipment order. It is best to call a sales rep. So what I do is I say, okay, based on the requirements, I'm going to need 2 48-port PoE switch. One of them needs to be a layer 3 switch because it's going to be doing the routing. So what I'll do is I'll say, okay, I'm going to surf the web. I go on Google, right? I go, okay, Cisco access layer switches. And once I get to the page, and sometimes it takes time to find these pages, I'll say, okay, well, products and services, I'll find the switches and all that. I'll actually take that guy, copy it to my clipboard, and then hyperlink it on my note. In OneNote, it's just Alt-K, brings up that bad boy. I just paste it in there. So that way, when I need to go back and reference it, I go, okay, this is the trail that I followed. Because like 90% of your day sometimes is just searching for stuff online. When somebody's like, what is your number one skill you need to be a good IT person? It's searching Google. That's it. Google skills are huge. So, and by the way, I don't know, here's my Google tip of the day. And this is handy. But there's a site, expertsexchange.com. They make you pay, but a lot of times you can, and they probably wouldn't want me to show you this, nor would, especially if it was my company, but this is handy for any site. A lot of times I'll be like, okay, I need, there's something going on with a Cisco 2960 VLAN issue. You can go site, Experts Exchange. And by the way, this is like one of 1,000 Google search tips, and that'll filter it down and say, okay, these are all the Experts Exchange ones that you can go to, and then you can get your answers and all that from there. But you can do that with any site. I can say, just filter it down to cisco.com and all that. So anyway, without a dot. So that's what I'll do. I'll hyperlink. I'll say, okay, I think the 2960s were a good fit, so I'll hyperlink that there, straight to the different models of 2960s. I can see how many ports are there, uplinks and 2 times 10 gig ports, or 4 times 1 gig SFPs. I can get all of my data from here. So I'll pull all that data together, and you can see I thought the 2960s would work great for layer 2. 3750X would work great for layer 3. Now, some of you might be thinking, well, how'd you get that? I mean, why did you pick those? And that's one of the thoughts that kind of derailed me early on when I said my brain checked out. I was like, oh, I should tell you this. How did I pick that? Well, I would say from talking to people, from just teaching this stuff, from just searching online, from seeing what other people have in their network. But this is where the sales rep really comes in handy. You want to give them a call and say, hey, this is my requirements. I need something layer 3. And the sales rep, that's their job. They spend 40 hours a week memorizing Cisco part numbers, and they go, okay, let me pick what I think would be the best parts, and here's why. They also will let you talk to a pre-sales engineer, which is usually somebody who has personality and can explain this stuff technically to you. Good people to talk to. But when you are designing a company, and this is totally not something CCNA or Cisco would want me to say or anything like that for CCNA studies, but you really got to peg your customer as to, do they really need Cisco switches? Yeah, I said that. It came out, but I will say Cisco is the top of the heap kind of switch. Like when you get a Cisco switch, I've talked to a lot of people, they're like, I buy Cisco because I can sleep at night. And I will say that is great because Cisco will let you sleep at night. It just keeps running and running and running. And yeah, you can pull out a horror story here and there of something that went bad, but I'm telling you, I've worked with Cisco for a long time and their stuff goes a long time. Yeah, yeah. Anyway, I won't go further down that trail. It's great, but you're paying a premium for it. I mean, when you're pricing Cisco, it's going to be probably the most expensive network devices that you can buy. So you really have to look at the customer and say, okay, is this something that they need? Do they need this level of stability? What kind of budget are they thinking about? You might go with Cisco Small Business. Now, a lot of people call them Linksys. Cisco has done a good job rebranding everything from Linksys over to Cisco Small Business. But I will tell you that Cisco Small Business makes some really quality stuff, which is probably a third of the price. Like a Layer 3 switch. I just picked one up for a customer of mine. A Layer 3 48 port gigabit Ethernet switch, which I know prices are always dropping, but I think I got it for $600 or $700. Something it was something I thought this is ridiculous, but it was a Cisco Small Business switch, and I thought, well, I think for this client that's all they're going to need. You really got to do kind of weigh the cost benefits of that, but also realize you're not going to have the iOS. But and that's one other thing I should emphasize. That's why I always emphasize the concepts when I'm teaching these things. If you know the concepts, you can apply it to any vendor's equipment, and Cisco Small Business included. And what's funny? Share a little insight. Cisco Small Business switches are coming off the same assembly line as most of the other vendor stuff. Throw Dell switches out there, throw 3Com, 3Com's no more, HP, all that kind of stuff. It's all pretty much the same hardware. Like literally, it's coming off the same assembly line, and they're just putting different logos on it, that kind of thing, because literally, when you get into the command line of some of these, it's like an iOS wannabe command line. And it's funny because Dell switches and Cisco Small Business switches, they're the same thing. It's literally, it's the same thing. Just logo difference is all it is. So anyway, enough on that. So you really got to peg your client. So based on this, I said, okay, from my searching around, figuring this out, my first choice switch, and you guys have probably read this whole thing already, so I'll go quick, would be this model of switch. I chose it because it's 48 port. I put this on there because I'm going to have to present this to the customer. And I'm just going to say, hey, this is 48 ports, layer 2 switching, 740 watts PoE. Has a big power supply, which gives 15 watts per port. That's big because a lot of times people sell these switches, 48 port switches, where there's only enough power for half the ports. Yeah, I've bought one of those and been very unpleasantly surprised when I get there and things stop lighting and I go, oh, that's not good, because they only provision enough power. They either assume that your devices that you're going to connect are only going to take half that power, maybe 7 watts or 8 watts of power, which sometimes is a safe assumption if you're just plugging in phones, or two, they only envision that you would plug in half your ports with PoE devices. So this will give enough power for 15 watts. That's the maximum the 802.3 AF PoE standard would allow. And then 4 1 gig SFP uplinks. That's good enough for me. It's a branch office. I know some of you are like, I want 10 gig. Yeah, me too. But it's a branch office. We're not virtualizing. We're not running a SAN or anything yet. First choice layer 3 switch, and I always put first choice because sometimes I'll put backups that I can, if the customer's like, whoa, that's expensive. 3750 layer 3 switch, same PoE capabilities, because I really envision a lot of client devices plugging into this as well. So I start thinking about, okay, how are these going to be mounted? Is MDF? Is there going to be a cabinet? Is there going to be a wall mount? What's going to happen? So I need to, and I put in red, determine server needs. So that would be my next on-site visit. I would, get with Windows guys, the guys who said they're going to be installing the 2 servers to determine cabinet. I figure 60 minutes for that. Windows guys always stock. So determine the lead. Cabling, I'm thinking, okay, a lot of spare cables. Fiber optic connections, can't forget those. Patch cables, couple SFPs. You want to make sure you buy the right kind of SFP for your switch. Also keep in mind those things can be pricey. SFPs, $200, $300 if you buy a Cisco brand. $20 if you buy the non, the quasi Cisco brand. So MDF, I'm also thinking 1 internet routers. Again, I hyperlinked it straight to the router page of this and of Cisco's website. 2900 series was my first choice router. Couple gigabit built-in interfaces, 4 slots. Voice capabilities, it's got onboard DSPs, that's digital signal processors, if we ever want to use it as a voice router to send calls to the PSTN. So IDF, you can see I just chose same model layer 2 switch for the IDF 48 ports. That should be enough for our 25 users up there. And then the building access points. I said, here's my Wi-Fi options. I will tell you what, look at this guy right here. I have had just some great luck with this thing. It's what is it? A 4410N, a little Cisco small business. That's what the customer said they wanted. It's not. This is Linksys quality stuff, but it's been really good. I've really enjoyed using these access points. They're really easy to configure. So 4410N, it's a 802.11n G and B, PoE capable, 4 VLANs, 4 SSIDs. I put that on there. Because the customer said they wanted a public and a private Wi-Fi. And the only way you're going to be able to pull that off is by having VLAN support on your wireless access points. So when somebody joins a certain SSID, say the public SSID, they're going to go on a restricted VLAN, right? So this is my brainstorming. Holy cow, guys. I'm so sorry. There's just so much to say about this stuff. I'm just looking at the time tick by. And it's again, so good. So, okay, so let's get into the equipment order. You okay with this? You okay going with me? I really think this is good stuff. So we've got my recommendations. I would now get on the phone with, and I'm pulling up my Excel spreadsheet here. Get on the phone with a sales rep and let them do their job. I say, hey, here's what I want. Sometimes I'll call in and say, what do you think would be best? And they'll get a pre-sales engineer. He'll say, I think this. They quote it out and go from there. In this case, I would call them and I would say, here's what I want. I'll let this. Oh, see if my. There we go. Okay, so I've got my equipment order right here, and this is just a sample, right? What I would do is I would say, okay, here's all of my devices. You can see 3750X, 2960. I just use my shorthand notation here. I come up with a host name for each one of them. NL, that's my Nugget Lab. Branch Office 1, B1, Switch 1. So this is the naming convention that I designed for the branch office. And now I haven't officially talked about naming conventions, but I will tell you, you got to come up with something. Sometimes people will just name it Switch 1, Switch 2, Switch 3, and that's fine. I will say I've seen people go way too far with a naming convention where it's like, this is S1X5J9B26-01-NL-INTL. You need like a full white paper to really even understand what this name means. For me, three pieces of the name has always just made sense. I do the company, like an abbreviation, so NL for Nugget Labs, or IN for Intel, or ML for Motorola. Something that you could come up with. And then what building or some kind of site identifier, like where in that company is this device. In this case, I put branch 1, that's B1, or maybe corporate would be C1, like corporate office 1. And then I put the device number. This is the first switch in the branch office, switch 1, switch 2, switch 3. Now you may look at that and be like, I don't like it. I'm saying, great, they'll come up with your own. Or you might look at it and be like, I love it. It's simple enough for me to grasp. Usually for me, simpler is better. If I can make it simpler without getting down to the level of having a host name of Switch or Switch 1, Switch 2, because as a consultant, a lot of times I'll forget. I'll say, oh, Switch 3, where was that? And now I have to pull out Visio diagrams and stuff. So that helps me out. So I put the device, I put a brief function where it's going to be located, and then I put the number of ports that I have on each one. You can see I've got my router right here, internet router. I've got my little wireless access points. I'd have Nugget Lab, branch 1, wireless, that's Y, the Wi-Fi device. RT is router, 1, 2, 3, and you can see all that. Now, I did not complete this entire thing, and I will tell you, don't spend too much time. This is where the sales reps come in handy. Don't forget the pieces. That's why I always run it by the sales rep first. As you can see, for instance, I've got the chassis. This is a breakdown of just switch 1, the 3750. I said, here's the chassis. That's what most people think of. Okay, that's the device itself. Well, yeah, but you also have to make sure you order a 4-port gigabit SFP module. They actually sell modules for these switches to add the 4-port gigabit module for the fiber optic cables. So you want to get that. You can get different modules. For instance, I put a redundant power supply in this guy. Here's the part number for that. You see how easy it is? Oh, we forgot the SmartNet for that. Oh yeah, we need the fiber SFPs, the actual modules that go in this network module. Four of these little SFPs. We need a rack mount kit for this to make sure that it gets up there. So you can see, and this I didn't even go down. I just went on Cisco's parts list for the 3750 and started putting some of these on here. The sales rep all have this tool called the Cisco Configurator. It's the magical tool that they say, hey, they need a 3750, and it's like, brrr, it gives all the options, and they just type them in, and it generates all the part numbers for them. So, my word, like just to create this little list right here, it took me about 30 minutes. That's not time well spent if you've got a good contact, a good sales rep that can put that together. So you'll get this equipment list, and you'll get the price list for it. So you'll want to then get back with the customer, make sure that this is what they want. A lot of times, I will say, as if you're looking at going into consulting, a lot of times you might want to let them order it from their vendor. You are in a whole new world if you want to start being the one who orders the equipment. You might think, oh, well, then I can mark it up, and then I can. Oh my word! I went that route because I thought, well, this is a way. I will tell you, if I could do it all over again, I would. And I should tell you, my consulting firm is a Cisco partner. I have a distributor relationship, but if I could do it all over again, I totally would just say to every customer I go through, I do the technical consulting. I will design, I will document, I will configure your network, but I will even give you the parts list that you need to go buy. But you need to go buy it from whatever vendor you choose. Go to the big guys, the Insights, the I don't know other company. The big vendors of equipment out there. Go buy wherever you buy it, because it has been such a pain in my side to keep the partner relationship going, to make sure I'm meeting sales numbers. And everybody nowadays marks their equipment so low that if you mark it up, you've got a customer who Googles it and they're like, hey, I could go buy this from Amazon for $100 cheaper than you. Are you trying to rip me off? And I'm like, no, I can't get the same prices as Amazon. I don't know how they do it. So anyway, all that being said, don't try and sell equipment. So, all right. Now let me talk about creating the documentation. I think this is going to be really valuable because, again, it goes back to the typical CCNA. Teaches you how to set up VLANs, how to configure them on switches. But when you actually get to a customer, here we are. Again, imagine yourself. Close your eyes if it helps. Imagine yourself going, okay, I'm this guy standing in the building. Unless your eyes are closed. Then imagine yourself being the guy standing in the empty building. And I need to design the IP addresses for this building. How do I do that? What is my thought process? Again, just put the best thing you could do is just try and put yourself there. You're staring at the sheet of paper. You're staring at the building. You go, okay, what subnets goes here? So that's where the discussion begins. Now that's where I'll bring back my project plan. 4 pieces of documentation: VLAN and subnet list, switch port connections, Visio diagrams for both physical and logical vision diagram, or Visio diagram. Physical and logical Visio diagram. Let me show you each piece, and I'm going to put all of these things into a zip file so that you're able to download them. Because again, the best thing you can do is have a template to start from whenever you're doing this. Whether you're working for a company, whether you're a consultant. Without a template, you're lost. You're just kind of shooting from the hip every customer that you go to. So I'm going to start off with a VLAN and subnet list. Let me bring that up right here. This is what I designed for the the Nugget Lab Branch 1 VLAN and subnet list. So here's first thing that I did is, here's the title, Branch 1 subnet and VLAN. I have network, mask, VLANs, and descriptions. So I'm saying, okay, what different networks do I need at this company? Well, first off, and this, again, I just came up with this, assuming that this is how it was. I said that at the Nugget Labs corporate office, remember they had a corporate, they started with 10.1.1 through 63.0. Now, this is a Jeremy-ism way of writing networks. That is not industry standard to do it that way, but that's for me an easy way to write. When you think, okay, 10.1.1.0/24, there's one network. Okay, 10.1. 2.0/24, there's another network. 10.1. You get the idea, right? 3.0/24, that's another network. So what I'm assuming is that I've got 10.1.1 through 63. So I've got 63 different networks at the corporate office that they're actually using. And actually, let me change that. Let's say 0 through 63 since that's where they begin. Now, do they really have, in this case, 64 actual networks over there? Maybe. Maybe they just said we want that big block because that's what we want to be able to use. Now, why is that block significant? Anyone tell me? Think about it. Why is 0 through 63 significant? Because it is one of the binary increments, as in you can summarize that whole corporate office by using your subnetting ninja skills that you developed through the regular CCNA series, right? You can summarize that whole corporate office in a single advertisement, which is 255.255.192.0. Now you might say, well, how did you come up with that? Well, again, you might go back and check out the CCNA series. I'm not going to go through all of subnetting here, but let me just show you quickly in my head what I do anytime I'm thinking about ranges or subnets or anything like that. Let me just see if I can clear all this off. There we go. What I did when I came up with that number is I said, okay, if I had 10. Let's say a whole bunch of subnets at the corporate office. Let's say they were actually using 10.1.0 through, let's say, 50 was actually in use at the corporate office. So 10.1.0.0, 10.1.1.0, all these individual different networks that they had over there. Well, what I would do is I would say, okay, that doesn't fall in a nice binary range. Like, for instance, if I were to increment that third octet by, let's say, 10.1.0.0, let's say I increment it by 16, 10.1.16.0, 10.1.32.0. No. See, this doesn't get me where I need to go. I want one advertisement. I want one big block that can sum up the whole corporate office. So maybe I say, okay, well, let me try 32, 10.1.32.0. And I know some of you are like, well, come on, you can just see 32 is not going to work. Well, yeah, I just want to show you. 10.1.32.0, 64. And again, I'm like, okay, well, they've got 0 through 50, so that crosses right here. This is 0 through 31. This one starts off at 32, so that's not going to work. So what I would do at that point is I would say, okay, I think an increment of 64 is appropriate for the corporate office. So I would look and I would say, okay, 10.1.0.0. 10.1.64.0. Okay. That makes sense now because that is 64, 128, 192. So that first network, let me fill in the end range. This goes through 10.1.63.255. The entire corporate office fits in there. Now, does it go a little beyond? Yup. That's okay. It's private addressing. It's okay. We can waste a few addresses. So what I did was I said, well, 10.1.0 through 63. And you might say, well, where'd you get that mask from? Well, once I realized that an increment of 64 is able to sum up all of this. By the way, this is route summarization in a nutshell. Once I realize an increment of 64 is able to sum that up, what I do is I say, well, how many binary bits do I need to go in the third octet? Because remember, when I'm figuring out a summary mask, a subnet mask for all of those, I'm going to look and I'm going to say, okay, well, all of these begin with 10. So 1, 2, 3, 4, and I'm thinking subnet mask here. There's 8 bits in the first octet. That represents the 10. Second digit is 1, and they all start with 1. You can see 10.1, 10.1, 10.1, 10.1. No matter how far I go down, it's all 10.1. So the second set of 8 bits are all the same. It's right here that the difference really happens. And I say, okay, well, the third octet is where the individual networks are being defined. So I would say that's where I want an increment of 64. Well, how many bits do I need to come over to get an increment of 64? Well, 2. 1, 2. 1, 2, 3, 4, 5, 6. Dot. 1, 2, 3, 4, 5, 6, 7, 8. So I would look and I would say, okay, good. So the network 10.1.0.0 with a subnet mask of 255.255, and then this, if I add up 128 plus 64, that gives me my 192.0. So this is a good summary mask for the corporate headquarters. Bring this back over here. So you see that now if you're looking, you're going, wow. That just blew me away. I would totally recommend you go back, check out the CCNA, the actual first CCNA series I did for CBT Nuggets. I spend literally hours going through from ground up subnetting, summarization, and all that kind of stuff. I just want to give you kind of the big picture of how I did that, how I came up with that. Now from there, I said, okay, now let's design the subnets for the Nugget Lab branch office. And what I did was I started logically thinking about the different groups or the different devices that are going to be on the network. I knew that I was going to have a bunch of voice over IP phones, 75 phones minimum to start off for the 75 employees, not to mention public phones and things like that that are going to be scattered around the office. So I thought, well, let's come up with a VLAN for that. Now, I have just been a fan lately of using this subnet mask, 255.255.254.0. What that does, just about everybody uses Class C. Whoop, wrong tool. Uses Class C subnet masks nowadays for things, but I like going one bit back from a Class C. So in this case, I use 255.255.254.0, which gives me, I'm not going to draw out all the binary, it gives me 10.1.64, if I were to write that out, 10.1.64.0 through 10.1.65.255. It gives me 512, actually 510 usable addresses that I can use for that. A subnet of 500 devices. Now, do I expect it to grow to 500? Probably not. But do I think that there's a chance it could exceed a Class C? Probably. If I'm thinking 200 employees, that's just employees. Not to mention the miscellaneous devices that end up on there, like, the servers that run the voice network, voicemail servers, that kind of thing. Extra phones for the lobby and the receptionist area and break rooms. I mean, it's just, you always need more addresses. So that's why you see I used a darker surrounding around here, so I can see that there's 1064 and 1065 are the two subnets, and then I did the same thing for the client. Now notice what I'm doing with my VLAN numbers. I'm matching them to the subnet. So when I see VLAN 64, I know that's going to be the 10.1.64 subnet. VLAN 66, I know it's going to match to that. So I have one for the voice over IP, the phones, one for the clients themselves. Now in a branch office this small, I know it's got a lot of devices, data, voice over IP, but in one I would say is just relatively small. I would only see one VLAN for the servers. And that's, or I should say, one VLAN, but 255 devices max, or 254 if you're purist, devices max for the server VLAN. This is going to be our domain controllers and things like that. I've got one for the public Wi-Fi, a separate VLAN. Now, why did I do that? Well, because when I put public Wi-Fi on its own VLAN, I can now restrict it with an access list. See, here's the idea. I've got my layer 3 switch, the 3750, which is going to link to two layer 2 switches. This is going to do all of the routing, and these are all my VLAN interfaces for the network. Now I know layer 3 switching is beyond the scope of the CCNA, but I'm telling you, buddy, everybody's doing it. So I've got to show it to you, at least in this series. So you'll have VLAN. We'll have 64. We'll have VLAN 65. Those will be our voice and data VLANs that we're using. So anytime you create a separate VLAN interface, and again, if this is a little mysterious, don't worry, I'll talk about it more later. You create a network that you can restrict. with an access list. So what we can do is set up an access list that says, hey, these public Wi-Fi people, anyone on VLAN 69 or part of this subnet right here, they are restricted to only reach internet addresses. Or I should say more specifically, I would engineer the access list to deny them from reaching anything but internet IP addresses. I would block them from all these 10. So I'd create one for public Wi-Fi. I'd create one for my private lab and my private workspace. Now you might say, well, what about the private Wi-Fi? You said there was public Wi-Fi, private Wi-Fi. What I would do is I would combine the private Wi-Fi with client data. Again, I've got 500 IP addresses. That should be enough for the wired and wireless devices. Should. Now that's everybody's got a smartphone nowadays, right? But that's where that fits in. So public Wi-Fi. I've got my private lab. You remember one of the requirements is that I could have my own office space in the MDF as long as it's separate from the corporate network. So I created its own VLAN for that. I've got a management VLAN. That's going to be the IP addresses that I use to manage all the different devices. Again, there's so much to talk about in this series. I'm excited about it, but I'm totally overwhelmed because I'm just like, wow, what did I get myself into? It's going to be great, but it's going to be a lot of stuff, a lot of good stuff. So the management VLAN, and then you can see right here, you're like, whoa, that did not follow scheme. I have the Internet DMZ. So let me draw up my design. I need a blank page. There we go. So let me take a little time drawing this one out so the whole picture will be clear. We've got, first off, I'm going to start off with our layer 3 switch up here. I'll draw an actual layer 3 switch icon, if you will. So that's what it kind of looks like. Layer 3 switch. That's going to be in the MDF. So we'll just put MDF connected to a layer 2 switch, also in the MDF. And a layer 2 switch in the IDF. I'll just put IDF right here. Location doesn't really matter. I'm just kind of mentioning it as we go. So all of these switches will be configured with the VLANs. So each one of these will have all the VLANs. We'll have VLAN 64, 65. This was our voice. This was our client VLAN. We've got VLAN 60. Or wait a sec. It was 60. Man, I got to look at my spreadsheet. 64, 66. Scratch that. Skipped one because of the extra. Yeah. So 66 is our client VLAN. We've got 69 is our public Wi-Fi, and so on and so on. All of the switches will have all of these VLANs. So for example, we'll have our clients coming off here. Well, actually, it'll be the IP phone plugs in first. Daisy chains to a PC. Now we'll be setting it up in such a way that the PC is on one VLAN. That'll be 66. The phone will be on a separate VLAN. That'll be 64. And we'll dive into that later. Man, as I'm doing this, I'm just like topic. All these topics are coming to my mind that I just want to talk about. So these will be configured as trunk links. Passing all those VLANs. Trunk link to both one of those switches. So they'll have, you've got your phones down here. They're in VLAN 64. You've got your PCs down here. Now let me add another piece of the puzzle. We've got our wireless access point. That's not a good color. We've got our wireless access point coming off right here. This is just one of them. We are actually going to configure this as a trunk as well. And that trunk is going to pass VLANs. Let me bring it into the picture here. VLANs 69, that'll be our public Wi-Fi. VLAN 66, which is our client, so this will be our private Wi-Fi. This will be our public Wi-Fi. And I'm going to pass VLAN 71. It's our management VLAN. I'm going to talk more about that later. So we've got VLANs, what did I put? 66 client, 69 public Wi-Fi, and 71 that'll have our management VLAN. So and this will be something. Actually, I have one of these wireless access points. I'll bring up this config later. Man, I'm just I gotta add these notes or else I'll forget. Hang on. Let me just write down W4410 config. So that way I'll remember to add this to the series. I'm just as this goes. So as a client joins the wireless network, he's going to specify an SSID. You remember from our requirements, I think it was going to be like Nugget. What was it? Nugget Lab Pub was the public. So if he joins that, the wireless access point will be configured to add him to VLAN 69. comes across the trunk on VLAN 69 up to here. Now this guy is special because he is the router for the entire network. And I'm gonna I'm writing this down. Layer 3 switching. Be a great topic to talk about later. This guy's gonna have an interface VLAN 69 with an IP address, and it will be, if I look over at my spreadsheet, it will be, let's see, public Wi-Fi 69, 10.1, 69.1. That'll be the IP address on the interface of this switch. That'll be this guy's default gateway. He's going to point to a default gateway of 10.1.69.1. He'll have an IP address of 10.1. .69 something. I'll just put 50 right there or something like that. Hand it out via DHCP, pass it right there, and that'll come up here. So it'll, when he wants to get off and surf the internet, it comes up here into this VLAN interface. Now, this is where I was all leading to before when I was talking about needing a whiteboard. This guy is going to be connected to a router right here. This will be our Nugget Lab branch Office 1 RT1, router 1, which will have a connection out here to the ISP. Okay, so our little public Wi-Fi guy will come in here, hit VLAN interface VLAN 69. It will route him out this direction, and now you've got the internet access. So that's logically how it works. But check this out. Physically, I want to show you how this thing will be connected. So here will be our switch, right? Same switch. It's our little MDF switch. This is Nugget Lab branch 1 switch 1. This will be our switch. So I'm just going to draw 4 ports on this switch. I'm going to have, and I'll show you my port list in just a moment, I'm going to have these 2 ports be VLAN 10. One of these ports is going to connect, actually I'll draw it right here. It'll connect to the router. That's actually this interface right here. Now you're seeing it looks like it's connected to the cloud, right? So that's what it looks like logically, but that is actually plugged into port 1 right here in VLAN 10. The ISP, this, I mean, they're going to come, if we were to look in your building, let's say that ISP is Quest. That's a ISP in our area in Arizona, Quest. Actually, now they're CenturyLink. They would probably pay me to say that. So they come in, they trench under the dirt, come in, install a wall jack. That is their point of demarc. And we all know demarc is where they point the finger at you if something breaks on the left of that. So that will come out here from the wall jack and plug in. Right? If I was to, logically, that will plug in right there. So I've got this little public VLAN where when this guy goes to the ISP, he's actually going into this switch in port 1 and out right here. Now, that VLAN 10 is totally separate from all these other ones. I mean, over here, physically, let's say, well, there's actually another design I have to add in there. Let's say this over here is just a normal client. It's a phone with a PC attached. This is VLAN, what is it, 64? And this is VLAN 66, right? These guys, even though they're plugged into the same switch, are completely separate from these guys. Now, let me, I know some of you are like, sweet. I always knew how that was. I've done that before. I love seeing that kind of config. Others are like, wow, that's totally new. That's kind of cool. I kind of get it. But let me tell you, if you are talking to a hardcore security auditor, I don't like these guys. And some of you might be security auditor. It's nothing personal. I like you. It's just I've had plenty of dealings where I've done designs like this, and they go, no, no, no. Security says this should be a completely separate switch than this one. You should not use VLANs to separate it because technically they're in the same switch. They could use something called a VLAN hopping attack to get off this VLAN and get in, so people from the internet could get into the inside of your network. And I said, yeah, right. If you configure your switch right, That's the big if, and that's probably why security auditors are out there saying no, 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 is because there's been plenty of cases where people configure the switch wrong, like they forget to configure this as a non-trunk port or something like that, and trunks can be negotiated. So if you configure your switch wrong, yes, it's a very big security vulnerability. I mean, you configure it wrong, you could put them in the wrong VLAN, and now the internet is bridged to your client network right past your firewall there. But if you configure it right, where these are in VLAN 10, they're access ports, everything's configured that way, it's good. I'm telling you, it's a good, solid security configuration. So that's just physically how it's attached. Now, let me talk about one thing that I actually forgot. This link right here. Couple strategies that you could take on this. One is to put this guy in your client VLAN. Meaning, I would on this switch, let's see our client data is 10.1.66.0, right? So I would create on this guy interface VLAN 66. That's our client. Again, our client VLAN 66 client data, right? And on the switch, I would put 10.1.69.1, and that would be the default gateway. All these guys would point to 10.1.69.1. Everybody following me, right? So he's like, I'm going 69.1, comes up to here, hits the switch. The switch says, oh, looks like you're trying to get to Google. Let's see where I send you. Well, on this switch, you would set up a default route. Default route is what? All zeros, right? 0, 0, 0, 0. So default route, all zeros, IP route 0000 space 0000 points to 10.1.69.2, which I would assign to this interface. 10.1.69.2. Okay? That's one strategy. That is one strategy, and I've done that before. It works. It works just fine, but I don't like it. I don't like it because it feels weird to me that this router is like just plugged right into the client VLAN. Like, to me, this is like, I don't know, it's like sacred territory to me. I don't like that the router's just there. It's right in the client VLAN. Even though it works, everything's fine with that. It works just fine. Here's what I like to do. I like going in and creating a separate little tiny point-to-point subnet just between these guys. It's a little private network. I feel like Bob Ross. If you haven't seen Channel 8, like public TV, Bob Ross, the panel, I need a happy little tree. I need a happy little subnet here. I need just like a little, and here's what I would do. And I kind of goofed up because it wouldn't be part of this scheme at all. Matter of fact, it wouldn't even be a VLAN. Here's what I would do. Squeeze it in here. I would do something like 10.1.254.0/30. And I would say this, oh, wait a sec. I can't, it doesn't follow my scheme. 255.255.255.252. No VLAN. Don't you love Excel and hate Excel all at the same time? How do you do that? How do you just put some dashes in Excel? It's not a formula. It is not applicable. How about that? And then right here, description, I'm just going to say point to point exit subnet. I'll normally call it an exit VLAN, but it's not really a VLAN. Here's how you would set it up. I would go on here on the switch, and I would put 10 dot, or what did I put? 10.1. I just came from a client today where everything was 10.10. 10.1.254.1/30. That would be this side. This side would be 10.1.254.2/30. How would you do that? Well, what you can do is you can go under the port. Let's say it's port 5 right here is actually this one. This is just this is a picture that builds. If somebody were to walk in and look at that, they would go, wow, I have no idea what that means. So this, yeah, you have to watch this to watch it build. It would plug in right here, and I would actually go under the interface configuration for this port, and I would type in the command no switch port. Anyone seen that command before? It's a good one. What that does is automatically make that port of the switch, this port will say fast Ethernet 0/5. That port is automatically a router port, meaning it doesn't participate in switching, it's not access, it's not trunk, it can't have sub-interfaces, anything weird like that. It's just a router port. Now I can assign an IP address. I can go under that interface and type in IP address. It's just like a router, right? If you've configured a router before. IP address 10.1.254.1.255.255.255.2. Set up my default route. Default route 0000 would say to exit, go to 10.1.254.2. I sure hope you're following. Man, I would love just to have you here, and you're like virtually here with me right now. So this would then be my exit port. So let's follow the trail. Guy surfing the net, let's say this guy, Happy Computer here in VLAN 66, says I want to go to Google. Comes up, hits interface VLAN 66, that's his default gateway right there. The router inside the switch, this is a layer 3 switch. Router inside the switch says, oh, you're going to Google. I'm going to route you, looking at my routing table, out that routed port to this router. Router receives it on 10.1.254.2 and says, oh, you're going to Google, and does its NAT deal and sends it off to the ISP. All of this we're going to be configuring. This is just like the ultimate design, kind of big picture idea behind all this. There's just so many concepts, and I think I'm doing too much. I can feel it right now. I'm doing too much in one nugget. Just keep in mind, if this is kind of fuzzy or like, this is going beyond the normal CCNA, it totally is. This, not on the CCNA. This, not on the CCNA. This whole thing, layer 3 switching, not on the CCNA. Cisco wants you to do a router on a stick, which is fine, it works, but I'm telling you, real world, not many people do a router on a stick. They're all, well, scratch that. There are plenty of people that do it, but layer 3 switching is it, man. That's where it's going to be in the next couple of years. So all of these concepts, I know maybe a little fuzzy, maybe you've seen them before, but that's how we're going to design our thing. So let's get back to the overview. Okay, so we're in the midst of creating documentation. Let me bring our ports back up. Okay, so that's kind of how I would design the VLANs here. Now, I want to show you this. Notice I put at the bottom of this branch 1 summary 10.1.64.0/21, or this subnet mask. That was not on accident. Remember how I showed you how I did the corporate office and I came up with that summary for them? Same thing for the branch. I said, you know what? 64 through 71, that could be an increment. So again, let's look right here. Oh, hang on. I was talking here about the 512 hosts IPs. So look back at my increments. You remember I used a 64 increment for the corporate office. That was going to be 10.1.0.0. Next increment, if I'm adding 64, 10.1.64. This is what I did earlier. So this is where the branch subnets begin. Right? So branch subnets begin at 64. They go 64 is 5, 6, 7, 8, 9, 10, 11 different subnets. So is that right? Did I do that right? Yeah. If I counted wrong, you get the idea. We've got this little group of subnets. So what I'm thinking when I'm looking at this, I'm going, okay, they're all in a row. They're all in a group that I could summarize into one single advertisement. This is summarization. So what I did, and again, I'll expand more on this later. I'm just trying to talk through my design. I said, well, what would be a good number that encompasses all that? If I have 64 plus 32, I'm going to be at 96. Obviously too big. 64 plus 16, I'm just adding these little increments right here. Well, 64 plus 16, that's going to be 80, right? So again, too far. I'm only going to 71 right here, not counting my little bizarre subnet of the Internet DMZ, and not counting this one I chucked all the way at the end, this point-to-point exit subnet. So what I'm looking here, and I know you guys, I'm just talking through it because I know many of you are like, I got the answer. Well, it's 8, right? I'm thinking of an increment of 8 because 64 plus 8 is 72. So if I were to look at this, add 8 to that, that means the next subnet would begin at 72. And maybe that's branch office 2 would be 72, 73, 74, 70, blah, 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 down this list. So an increment of 8 would actually create a range that would go from 10.1.64.0 through 10.1.71.255. That would be the last address encompassed in that. So I'm like, great, that's perfect, because that catches all of these different subnets all the way down through 71.255, which would be last IP address in my management VLAN. And I could summarize all these into one route advertisement. So well, how did I come up with this little mask then? Well, what I did was I said, well, 10.1, that's first 8, everything starts with 10, so the 8 bits there are the same. Everything has a 1 as the second octet, so again, I'm thinking subnet mask. That's 1, 2, 3, 4, 5, 6, 7, 8, dot 1, 2, 3, 4, 5, 6, 7, 8. So 255.255, because the first two octets are all the same. This third octet is where the differences begin, and I want an increment of 8. So to get to 8, I have to go 1, 2, 3, 4, 5 in on that. So dot, and this is the third octet where the changes are happening. And trust me, this is total shortcut dreamland for subnetting. Just once you do it long enough, this just kind of all works out in your head. And I'm going, okay, that's 5 bits. That's going to be 248.0. So a summary mask that would encompass would be 10.1.64.0 with a subnet mask of 255.255.248.0. That is a nice little summary for my branch office. So I wrote it both in decimal notation right here, 248.0, and the CIDR notation. So I did not go beyond 71 on purpose. If I had to go beyond 71, fine. But then my summary mask, I would say let's use a 16, and then branch office 1 would actually have all the way up through 79.255 would be the last address instead of 71.255, because I would have an additional 8 subnets that get thrown in there. So good. So let's look at the VLANs, and I'm going to just kind of show you my documentation. Once I not only I go in there and create the VLANs and say these are the subnets, here's what they're used for, I then go through and I document every single IP address. I know some of you are like, you're kidding. Who would do that? A good network admin. That's who. Seriously, I'm not just saying, oh, I'm a good network admin, because I'm telling you, there have been some networks I have designed, and I look and I shake my head in shame. I'm like, Jeremy, you are shamed. And I am embarrassed when I bring somebody with me to maybe work on the network. They're like, wow, who did this? I'm like, yeah. So okay. So yeah. As soon as I have to start making excuses, I know it's not a good job. So I've learned over the years. I'm trying to pass this on. Every single IP address. Now I'm not saying, for instance, this is the client voice over IP VLAN. I'm not going to say, okay, 11 is an IP phone, 12 is an IP phone, 13 is an IP phone. I'm not going to do that. I'm going to do a nice big range here and say, okay, 10.1.64.11 through 10.1.65. That's hundreds. That's almost 500 addresses right there. That's the DHCP scope for the client voice over IP. So I'm assuming all of those are going to be handed out to individual clients. Notice I then went through, and what I typically do when I have a big subnet like this is I reserve the first 10 and the last 10 IP addresses of the subnet, and I say 10 or so, of the subnet, just for network stuff. I mean, I might have to throw a device on here, like this might be a call manager server, that I need to install on that subnet, and so I'm adding it in, so I'm already provisioned for that. But literally every IP address needs to be documented. There's a lot of automated utilities that will help, but I'm telling you, I've used them and they cause me to get lazy, and I stop really documenting. Like SolarWinds has a little automatic IP address tracker, which is great. It's a little, I think it's free still, maybe not, but I get lazy when I do that. I'm like, oh, it's just happening behind the scenes. Something's tracking all that, and I start losing track of things. So you notice the first IP address from every subnet is going to be Nugget Labs branch 1 switch 1. VLAN 64IP. That's going to be the default gateway for everybody on that subnet. And as you scroll down, I went through as an example. I really worked hard on this, guys. Look at this. VLAN 66 client data. I've got the data network. This is the network ID. Down here is the broadcast. You notice I've got my DHCP scope. I started throwing in a couple things, like for instance in the client VLAN there was this Xerox color printer, so I used one of those typically reserved addresses at the end of it. HP LaserJet printer, so I'm documenting the static IP addresses that I set in here because later on this is going to be invaluable to you when you're adding a new printer, having consistency on the network. I will say I have met some people. There's a friend of mine named Kurt. The guy is amazing. He does everything in his head. He documents nothing ever. And I'm like, how do you do it, dude? He just has one of those photographic memories. I don't. I need to have documents. So server, and he laughs at me. It's funny. Hang on, let me show you. I always hate it when I do spontaneous things like this because I know I'm gonna someday compromise some critical things. But anyway, I was just doing this project last night. I was up till 1 in the morning or something. I'm setting up a free PBX, free PBX, like an Asterix Linuxy system. And I was just documenting as I was going. There's a little 3-com switch I was configuring. And actually, I go figure. I was configuring it for a layer 3 switch. I was setting up a VLAN ID of 80, giving an IP address. And so literally, I'm going through and I document every single thing that I do. I'm going into setting up the IP address, free PBX system, moved it onto a specific VLAN, and I can't go any further because I'm sure I'm going to start crossing passwords and stuff like that. But literally, this is a 4-page document I created, just documenting every step, and I emailed it to him. He's like, I can't even look at that. It's too long. I can't believe how much you document. He mocks me for the amount I document. So it will save you. I will say that. So anyway, server VLAN right here. We've got all the IP addresses. Here's my 2 IP addresses allocated for the Windows servers, DC01 and DC02, domain controller. Here's a call manager business edition, which is a small office call manager essentially. I've got my management VLAN down here. Take a look at this. What I do is I assign a management IP address to every single device, and by putting it on its own VLAN, only the people or devices that I choose can have access to this. I can filter access to all the management interfaces of my system. Likewise, I've got my internet DMZ down here at the bottom. These are my public IP addresses the ISP gave me. Notice they're all public. So I just named our ISP Galaxy Quest. ISP Gateway might be the .241. The external IP address of my router is this .242. Then all these are unused. So these could eventually become static maps. So I could let me get back to my picture here. Oh, that's scary. I could have servers or something sitting off here, like little web servers on this network. That I could create a static NAT mapping with one of those public IPs, that when somebody hit that public IP, this guy automatically translated it back to this web server, and it served web pages and things like that. So that's the first piece. That's documenting all of the VLANs and subnets. Now I know some of you look at that and you go, awesome, I love it. Some of you think, my word, I can't believe you do that much documentation. I will tell you, initially, it will be a discipline for you. You're going to sit here and go, this is a waste of my life. Because I was there. I've said that many times. I'm like, I can't believe, oh, Excel, why did you do that? I can't even put a minus sign here. It becomes frustrating. But after you do it, I'd say give yourself, it's like any good habit, give yourself a month of just doing documentation for everything. Literally everything. Your wife or husband calls you. They're like, pick up pizza. I'm like, pick up pizza. Step 1, drive to Domino's. Step 2, order pepperoni, whatever. So document everything. And by the time it's said and done, you're going to be like, how did I not do this before? How did I live not being able to do this? So, okay, so that's VLAN subnets. I feel like I'm so time crunched because I'm trying to get everything in here. Let me show you the ports. Ports is where you go to each switch and you document exactly. And I know some of you are like, wow, were you really going to do that? I really am. Every single port that has a key device. Now, for instance, I'm looking at this is switch 1 right here. Branch 1, switch 1. If these are all connected to clients, what I would do is just type in client. If there's nothing in them, put nothing. I mean, unless you have a reserved port or something you want to make sure that nobody uses, you can have that too. So this is our switch 1, and notice I've got VLAN 10. This is my little public DMZ VLAN right here. VLAN 68, little server VLAN where I've got my domain controllers plugged into. Now notice I have this. I put in here gig Gigabit Ethernet 0/7 is assigned to VLAN 68. I've got DCO1 LAN 1 interface of that, and I just put it's Windows Server 2008 R2 server. But notice down here I've got switch 2. Almost every server that you buy nowadays will have redundant interfaces. So I have one plugged into switch 1, one plugged into switch 2. You can see this is the LAN 2 interface of DCO1. So that way, if I lose one of my switches, the servers stay online and people can still access all the resources on there. I also wanted to show you how I typically document client. You can see, for instance, this is a phone/data VLAN. So I say this is a voice VLAN. I'll show you how to configure this later. And a data VLAN. I just say, hey, these are all clients plugged into a NIC. I don't have to say what client it is. I mean, if you really want, bonus points, you can. But wow, I mean, at that point, your documentation is changing so often because people always move things around on the client side. So I just usually say, hey, the clients are plugged in here. So that is the ports. Last thing I wanted to mention, let's see. Creating documentation. Okay, so hang on, let me go back to my project plan. A little task list here. Last thing I'm going to show you here. And then actually, I'm going to dedicate the whole nugget following this just to physical. I have right here beginning the installation. That'll be the whole next nugget because there's just so much to say. I want to show you the last thing, which is Visio diagrams. I don't like Visio. I don't like it at all, but I've learned to tolerate it just because everybody uses it and it's good for creating documentation. It's just anytime I think of creating a Visio diagram, I just think this is going to be at least 2 hours. 2 hours is like my penalty just for using Visio because everything connects to the wrong things. I've got connector lines shooting everywhere. So first off, let me shrink this down. This is the physical layout. What you will do when you document this is literally show where things are going in the rack. Now this is before you install. This is not something where you install it and then go, okay, let me create a Visio diagram. Sure, that's better than no diagram at all, but this is before you do it because there's nothing worse than getting there and finding out you don't have enough space in the rack or something doesn't line up right. So what I have here, and I know this is micro-sized, it's just the font I use. I've got a little 2U patch panel, a couple 48 port patch panels. Oh, look at that. Hey, Visio did something right. So I've got my, there we go. So got my patch panel. Got my patch panels here. I've got my cable management. So you can't forget, a lot of times you got cable management. I've got my switch 1 and switch 2. This is the MDF rack, a little 42U full cab. This is my Cisco 2901 router. Now, with Visio, for me, if I can't find an icon, I just put in a blank space and put that's my router. Because, yes, I know some of you are like, you can go download Visio templates. Yeah, it's just time. It eats up my life. Another cable management. Here's my 2 domain controllers, 2 little 2U servers and cable management. So right there, I say, okay, my physical rack for the MDF totally got enough room. So that one is good. Over here I have the IDF. I just got a little 21U wall mount rack that I went in and put in that place. So that's, I mean, it's again just a sanity check to make sure that all the stuff that you think is going to go there will actually fit. And you can, for instance, one thing I didn't mention is you got all the plugs. You can't forget your power. There's just stuff you don't think about until you actually put it up there and go, oh yeah, I need power. So that's the physical diagram. I just did a quick logical diagram. I do these just for myself so I can see it. It makes sense. This is actually usually one of the first things I do when I'm brainstorming. I say, okay, I think it's going to connect like this. I've got redundant cables here. That's going to be a little ether channel from the MDF to the IDF. There's my switch 3. Usually I'll put on IP addresses. Usually I'll actually label the ports. I'll put on, for instance, put on the port like this is gig 0/1, but I don't put it on the middle of the port. I put it on, by the edge, a little text box down here, so I know what ports are connecting to what. But you don't have to do that, again, because on that Excel spreadsheet, is one thing I found. I kind of used to over document to where I would put all the port connections on the spreadsheet. I would have it on the Visio diagram. So if I ever moved a cable, I had like 5 different documentation pieces to update just to say, oh nope, this is connected here, connected here. So I started pulling back on actually putting the ports on the Visio diagram. Keep that on the Excel spreadsheet. This is just more of a visual to let you see how this is going to work, how things are going to logically flow in this network. Whew. All right. I'm slowing down. I know it's funny. I where was I? Oh, I was at a trade show with CVT Nuggets. Just come to shake some hands, and there was a guy who came up to me in the booth, and he's like, "Hey, I've listened to a lot of your stuff. Just it's good to meet you, all that kind of stuff." And I started talking to him. I'm like, "Oh yeah, what do you do? Where do you work?" And I was finding out about him, and he goes, it's funny. He said, I've been listening to you on double or triple speed for so long that when you talk now, I'm like, okay, yeah, go faster, go faster. And it's funny because I was like, you know what? Sometimes I talk so fast in those videos, like I'm just trying to get everything in, that I'm like, I don't even know how people do it. Listen to me on the double and triple speed. It must be like, whew. Anyway. So a lot of info, and again, just doing this, I think, was good for me. I think it's good for the series. This series, by the way, is one of the first at CVT Nuggets where we're going to do it this way, or it's going to kind of be released as it goes. As this nugget is done, and it's going to be released, and we're going to get feedback from everybody and be like, oh, what about this? What about this? People are going to be suggesting topics and all that kind of stuff. It's going to be cool. I'm really excited about this. So, a ton of topics already in my little note card that I started right next to me. Really what I wanted to show you between this nugget and the last was how to initially start the project. Because again, a lot of times you start and you're like, okay, I want to get in and configure something. Days of planning should go by before you're ever in the iOS, before you're ever doing anything like that. And this just gives you an idea of some of the things that you have to think about, some of the things you have to plan about as you design these networks. So I hope this has been informative for you, and I'd like to thank you for viewing.